Hello, we're just going to look at quartiles and box plots in this video. So I'm going to go through just some information about finding quartiles and representing them using a box plot. So quartiles, as the name suggests, divide the data into quarters. Okay, so you've got a quarter of the way through, which is Q1 or lower quartile, halfway through, which is the median or the second quartile, and the upper quartile 3/4 of the way into the data. So the way that you calculate quartiles is different for discrete and continuous data. For individual values, so discrete values, you use n+1 and divide by 4, divide by 2, etc. to work out the position of the quartile. So I'm just going to demonstrate that. The lower quartile, we would do n+1. So n is the total frequency. So in this case, there's 23 students. So 23 plus 1 divided by 4 gives us the sixth value. So the lower quartile is the sixth value. Really common mistake people make is to write that the lower quartile is 6. So they find the position and write that as the answer. But that just tells you whereabouts the lower quartile falls. So you find 6th position, assuming you've got your data in order already. And then the median, or the second quartile, n+1 divided by 2, tells you that it falls in the 12th position. And the upper quartile is 3 times n+1 divided by 4. So basically 3 times the lower quartile position, which is the 18th value. And in this case, it's 9. Okay. So second demonstration very quickly here. 15 members of a golf club. So we're going to do 16. 15 plus 1 divided by 4 to find the lower quartile position, which is the 4th. Median will be n+1 divided by 2. So that's the 8th position. And the upper quartile, 3 times n+1 divided by 4, tells you it's the 12th position. So we have the upper quartile in the 12th position. So just an important note, if you're working with continuous data rather than discrete. So continuous data that is measurable. So length, mass, weight, height, that kind of thing. You simply find halfway, quarter of the way, 3/4 of the way through the data. The n+1 applies to individual values only. Okay, so important to remember that. Quartiles allow us to compare 2 sets of data. Okay, so we're given a second set of data for another golf club here. And if we go on to the next slide, and you can go through this in your own time on the PowerPoint if you need to. The interquartile range is calculated by taking the lower away from the upper quartile. Okay, so not the positions, the actual values. And it will tell you how spread out the data is around the center, if you like. So how spread out it is around the middle 50% of the data. And that in context, that tells us how consistent the data is. So a smaller IQR means that the data is more consistent, it's less spread out. Higher IQR would mean it's more spread out. Okay, so if we look at our golf clubs, we can see from taking away the lower from upper quartiles that the interquartile ranges of 33 and 27. And this shows us that the data, or that the ages, which is what this refers to for Golf Club A, are more spread out than the ages for Golf Club B. Okay? And in context, we could write a sentence, something like this. Members of Golf Club B are more similar in age than Golf Club A. You could just equally say members of Golf Club A have ages which are more spread out than Golf Club B. Okay, they're less consistent. And always, when you're answering this kind of question, refer to the numbers. So you would say members of Golf Club B are more similar with an interquartile range of 27 compared to Golf Club A, which has an interquartile range of 33. So don't forget to use mathematical language and support it with numerical values. Okay, so a box plot shows the quartiles and the minimum and the maximum. Okay, and if you have two box plots on the same graph, it's a really good way of being able to compare visually the data. Okay, box plots look like this, and you should have all come across this before. You'll have a scale at the bottom, so you'll have your axes with your clearly labelled scale, and your minimum value and maximum value form these two whiskers at either end. These are called whiskers. Sometimes it's called a box and whisker plot. Okay, and the lower quartile, the median, and the upper quartile form this kind of rectangle, and it's obviously very clear. Sorry, just jumped accidentally. Very clear to see the shape of the data. You can also see if there's any skew, any positive or negative skew. Okay, so if we look at, just very quickly build this one. This is a box plot representing math test scores. I have a feeling the bottom of this might be a little bit off the video. And you can see you've got the scale along the bottom, clearly labelled math test scores, and you can see the minimum values at 3, lower quartile, median, upper quartile, and the maximum value. If we put two of those side by side for 23 female students and also a set of male students underneath, it makes it really easy to compare. You can see the median for the boys is lower at 7 than it is for the girls. We can see that the boys' results have a much larger interquartile range and therefore are less consistent than the girls' results, which are less spread out. Okay, and in fact the whole range, which is the largest, the maximum take away the minimum, the range is greater for the boys than it is for the girls. Okay, so again, when comparing data, make sure that you're using mathematical language. Okay, and also see that there's a negative skew with the girls because the majority here of the interquartile range falls below the median. Okay, so there's a negative skew. There's a slight negative skew here as well, actually, with the boys. So it's just some statements which we could use to conclude, use this data to conclude. Okay, so your next task is simply to complete the questions on MathsWatch. You can watch the MathsWatch video as well, which will go through this again. Complete the questions on MathsWatch, and then there's an extension task, which is a harder question, slightly harder question for you to complete. And this looks at how we can use interquartile ranges and quartiles to calculate outliers. So you know an outlier is obviously a piece of data that's quite significantly different from the rest of it, and perhaps before you've only really calculated outliers in terms of the fact that they look quite different. But there is actually a mathematical way. An outlier is quite simply a piece of data that is 1.5 times the interquartile range above or below the upper and lower quartile. So for some of you, particularly those of you which are looking for a higher grade, it would be useful for you to complete this question. And I have put a piece of graph paper on the last slide, so if you don't have any access to graph paper at home, you could print that off if possible. If you can't print and you haven't got any graph paper, then I guess ruler and pencil, make yourself some squared paper and draw your box plot on that. And if you could send your answers to Mr. Wilson or myself, that will allow us to then mark the extension task. Okay, thank you for watching.